Hello. In this video, I'd like to show you how to solve a linear system using equations and algebra. There are lots of ways that you can solve linear systems, but in this case, let's focus on the equations part. I recorded another video solving this exact same problem using a data table, but in that one, we talked about some downsides to relying on data tables and how equations could actually make it much quicker and easier, and that's what I'd like to show you here. So in this problem, this is about two birds that are flying toward one another, an eagle and a pigeon. And that's what a linear system is. It's just two things or two people or two situations where there's a constant rate of change. And that's what we have in this case. It says an eagle soaring high above spots a pigeon lazily flying below. It's mealtime for the eagle, so it decides to dive down and grab it. The eagle starts 200 feet above the ground and descends or flies down at 12 feet per second. The unsuspecting pigeon was 65 feet above the ground and is flying upwards at 3 feet per second. After how many seconds will the eagle grab the pigeon, and what will their height be above the ground at that time? So that's the situation that we're dealing with here. So when are they going to meet? So the first thing I have to be able to do is I have to write equations that will model the height of these two birds over time as they're flying. And this situation, there are two variables here. Time is ticking by throughout their flight, and their height is changing as they're flying. So let's have x be the number of seconds, and let's let y be the height of the bird, of each bird, in feet. So how do I write an equation to represent these? Well, not too complicated here, and the way I like to think about it is the height of each bird as it's flying, the height is going to be equal to its starting height plus or minus the change in its height, how much it flies up or down beyond that starting height. So if it's flying up, we're going to have to add that change in height. If it's flying down, we're going to have to subtract away that change in the height. And how do we figure out how much change in height it has? Well, if I know the rate, feet per second, and I multiply that by the number of seconds that it's been flying, that will give me how much the height has changed, and then I can just either add or subtract that from the starting height. And that will then give us the equation in slope-intercept form. Y equals mx plus b, or if I turn that around, y equals b plus mx. And I'm going to write it in this form here. I always like to start with the starting amount and then add or subtract from that. So I usually like to write it like this. So let's get going on that. Let's write these equations. So we'll start with the eagle. So the eagle. So its height, and we said that the variables we'll use are y and x. So its starting height y is going to be equal to the starting height of 200 feet. Starts at 200 feet. And it's going to descend. It's flying down at 12 feet per second, multiplied by the number of seconds. So there's our equation that will determine the height of the eagle at any time, x. Let's do the same thing for the pigeon. Pigeon. The height of the pigeon is going to be equal to its starting height of 65. In this case, it's flying upwards. So I'm going to have to add to its starting height. It's flying upwards at 3 feet per second times x seconds. So there are the two equations that we're going to be dealing with in this case. So the question we have for us now is, what value of x do I need? How many seconds will it take for these two equations to produce the same height? What x do I need so that this is the same as this? When will these be the same? So here's how I'll do that. It's actually not too tricky. I want to know when these are the same. What value of x makes these the same? So let's go 200 minus 12x. That's the part from the eagle's equation. and make that equal to the pigeon's equation, 65 plus 3x. So now now that these are set equal to one another, solving for x will tell me how many seconds are necessary for these two to give me the same height. So let's just solve. So I've got starting heights and these x terms on both sides. This would be a lot easier if I could get rid of the x term on one side. So let's just do that. Let's start by getting rid of the x term over here. The opposite of 3x is minus 3x. So now it's just gone from that side, and 65 is all by itself on the right-hand side. But if I take away 3x's from one side, I have to take away 3x's from the other side. And what does that leave me with? Over here, I still have the 200, but negative 12x minus 3x is negative 15x. So there's my new equation, a little bit simpler than the last one. 200 minus 15 times x is equal to 65. Let's keep solving for x. So let's get x by itself. Let's get rid of that 200. The opposite of plus 200 is minus 200. If I subtract 200 from one side, I have to subtract it from the other side. And let's see what remains. 200 is gone, but I still have a negative 15x over here. And on the right-hand side, 65 minus 200 is negative 135. Now I've got one step left. Negative 15 times some number of seconds is equal to negative 135. How do I solve for that one? Well, the opposite of multiplying is dividing. If I divide this side by negative 15, negative 15 divided by negative 15 is positive 1, leaving just x over here. And if I divide this side by negative 15 as well, negative 135 divided by negative 15 is positive 9. In this case, for these two to be the same, I need x to be 9 seconds. So there I've answered the first part of this question. How many seconds will it take the eagle to grab the pigeon? I know based on these equations will give me the same height when x is 9 seconds. But that's only half of the problem. The other half is, what will their heights be? How high above the ground are these two birds after 9 seconds of flying? And for that, I can use the equations to calculate that too. So there are the equations for each bird. Y is equal to 200 minus 12x for the eagle. Y is equal to 65 plus 3x for the pigeon. I can use either equation now to determine their heights. As long as I take that variable of x and I substitute 9 in for x, I can now solve for the height. And so I did it for both birds. You don't have to do it for both birds. You can just pick whichever one looks easier. To me, I probably would have done this one. These numbers are smaller and easier to deal with. But if I just multiply, and then here 200 minus 108 is 92. But here for the pigeon, 3 times 9 is 27, and 65 plus 27 is also 92. So now I know that these two birds will meet after 9 seconds of flying when they're both 92 feet above the ground. And there are your two solutions to this problem. So I recorded an earlier video where we did this with a data table, and we talked about the pros and cons of using that method to solve this linear system. Let's briefly look at the pros and cons here. Pros: fewer calculations. I didn't have to keep adding and subtracting over and over and over and over. I had some calculations in the equations to deal with, but I didn't have to do 50 additions or 50 subtractions. Another pro: if there were decimals in this problem, it wouldn't be a problem. Solving equations with decimals is not really any more difficult than just dealing with whole numbers. And even if the answer were a decimal, if it were 9.3 seconds instead of 9 seconds, the equation could still handle that no problem. So I really like solving with equations. But the cons, if you're going to use this method, it does require you to understand what the parts of a linear equation represent. What does y mean? What does b mean? What does m and x mean? So it does require some knowledge of these equations. It requires you to write two equations to represent the two flights of the birds, and to know how to solve for x and for y. So here we solved for x, and then we had to use that x value to solve for y. So it does require you to know how to do both of those things. But overall, I definitely like solving these linear systems with equations. I hope this was helpful, and I hope this makes sense. And good luck as you solve these problems.